Hi guys, welcome to part 3. So today we're going to be adding in a character and setting up some of its animations. But first there's a bug that was pointed out by a viewer in part 2, which is just that collisions don't work when you come in at an angle like this. So we can fix this by going into the player physics, and after we do the vertical and horizontal collision checks, we're going to do one more collision check that will be in the direction that the player is moving. So we can get the player's direction just with let's create a new vector 3. We can just call this player direction equals new vector 3, and for the x we want delta x, and for the y delta y, and we can just ignore the z because that's 0. And now we want to set the origin point of the ray, so we want that to be at the corner that is sort of leading the cube, or the player rather. So for example, if the player is moving to the left and down, then we want that to be cast from the bottom left corner. So we can create a new vector 3, and we can call this O for origin, equals a new vector 3, and for the x value, well, we can just copy the x value that we used in our horizontal collisions, and for the y, we can use the y value that we used in our vertical collisions. And the only thing that we need to change is these directions. So for the x direction, that is the sine of delta x, and for the y direction, that's the sine of delta y. And once again, we can just ignore the z value. Now let's see how this is working. So let's put in a debug.drawRay, and for the origin point we can have O, and for the direction, player direction. And because this is a direction, we actually want to get the normalized value of this, so that's with a magnitude of 1. And now we should be able to see what's happening. Let me just hide this mesh renderer. Okay, and you can see over here in this view how there's a little ray cast from the corner in the direction the player is moving. So that's exactly what we want. Now we just have to make that function as an actual ray. So back over here, we can say ray equals new ray, and for the origin O, and for the direction player direction, and once again we want to have the normalized value of that. And now we can say if physics.raycast ray, and for the distance, well, we want to get the length that the player is moving, so we use Pythagoras' theorem, which is just mathf dot square root of, and we want delta x squared plus delta y squared. Okay, and for the mask we can just use our collisions mask, and I think I need one more bracket. Yep. Now if it collides, then we can just say grounded equals true, and delta y equals 0. And we only need this to execute if collisions weren't detected vertically or horizontally. So we can say if not grounded and double ampersand not movement stopped, then we can put all of this inside that. And now collisions should be working diagonally. And they are. Good. So now we're going to be importing our character. So let's create a new folder, and we can call this models. And into here you can import your character. If you want to use the same character I've made, then you can download that from a link in the description, but more than welcome to use your own. So you can see he's just got 4 basic animations set up. The one is just a sort of headband wave, sort of waving in the breeze. The next is just an idle animation, which is just completely still. There's a simple run animation, as well as a very basic walk animation. So the first thing we want to do is I'm going to go through all of these and just tick the loop pose box so that they loop. And after we've done that, we can just hit apply at the bottom here. And now let's drag the player into the scene. And the first thing we can see is that he is absolutely massive. So I'm going to want to scale him down a bit, say to about 0.3 maybe. Okay. And now we want this to replace our player prefab that we have over here. So let us just copy these components. So we'll copy the player physics as well as the player controller. Just copy and paste. And now we can just drag this onto this prefab and just say replace anyway. So now this is our new player prefab. And we can fiddle with the box collider now to make it encapsulate the player. So let's see what we want these values to be. So we can put this at about a 5.1 maybe. And then this must then be double that, so 10.2. And that looks about right. And for the X, put it there, and we can just offset this a little bit. And the Z doesn't matter at all since it's 2D, but I'll just put it like that anyway. Now, let's apply these changes to the prefab and just disable this since we're instantiating the player at runtime. And we'll see things aren't quite working how we want them to. So first thing you'll notice is that the player is just going through stuff, really. And you might not have this problem if you've used your own character. We're only having this problem specifically because we scaled this down. And if I were now to just show these rays that are being drawn, we can see that when we stored those variables for the collider size, we didn't take into account that the scale might not necessarily be 1. So what we're going to do, and this is also going to help us later because we're going to want to be able to resize the collider easily. Say if the player slides or something, we're going to create a public void called setCollider, and it's going to take in 2 vector 3s. The one's going to be called size, and the other one center. And in here we can just say collider dot size equals size, and collider dot center equals center. And now we're going to want to update the size and center, the current size and center variables that we have that are being used in the calculations. We'll say center, or rather let's start with size, equals size times collider scale, which is a variable we'll set up. And same thing for center, center equals center times collider scale. And now, over here, we're going to create 2 more private vector 3s called original size and a new private vector 3 original center. This is just that we can reset our collider at any time. And over here, we're going to say original size equals collider.size, and original center equals collider.center. And then at the end of this, we're going to say set collider, and we're going to pass in the original size and the original center. Okay, and now we're also going to want to set a private float called collider scale, and we'll set this first over here. We'll say collider scale is equal to collider, oh actually no, not the collider, but the transform dot scale, or the local scale. You can just say .x. We're going to assume that it's scaled the same across all the axes. It's definitely bad practice to have it not uniformly scaled. And now, let's see if things are working a little better. And you can see that they are. But we've still got this problem in that these rays are so spaced out now that the character is so tall that they're not always colliding. So what we're going to do is we're going to make a variable that will determine how many rays that we're going to have cast from the sides and from the top and bottom. So we'll create two private ints, one called collision divisions x, and the other collision divisions y. And for the x, I'll just set that to 3. So these will be the ones going along the top. And collision divisions y will be how many go in the y-axis, so coming up from the sides. And we want to increase this to something like 10. So now we can go here, and for this for loop, we want to replace 3 with collision divisions x. And you can see over here what we were doing was we were adding each time size.x over 2. But what we really want to be dividing by here is whatever this number is minus 1. Okay, so we can divide by collision divisions x minus 1. And we do exactly the same thing over here for the horizontal collisions. Place 3 with collision divisions y, and instead of dividing by 2 over here, we divide by collision divisions y minus 1. And now we can see that we have 10 collision lines here and 3 there. So basically all we'd have to do is find the smallest object that we want to have our player able to collide with, and then just make certain that it isn't smaller than the distance between these rays, and that way we can be sure that the player will be colliding with everything that it needs to collide with. So now let's set up our animations. So first thing we need to do is we need to create a Animator Controller, and we can just call this player animator. And let's enable our player over here, and we can drag the player animator onto the Animator Controller in the Animator component, and just turn off apply root motion over here. And we'll apply this, and we can disable the player again. Now let's double click on our player animator, and this will open up the animation view. So what we want to do is we want our player to be standing still or walking or running based on the player's speed. So first actually let's add in the ability for our player to run. So go into Edit, Project Settings, Input, and let's add in a run button. So I'm just going to change the size of this to 4 since there are way too many things here. And I'll add in jump again since it deleted that. Positive button is space, and here we can call this run, and the positive button can be left shift, and the alternative positive button can be right shift. And now if we go into the player controller, we're going to replace this speed variable with rather a walk speed and a run speed. Okay, and we can set run speed maybe to 12. And now over here we can see in the input that the target speed is being set by the direction that you're pressing multiplied by the speed. So now what is the speed? The speed, we can create a new variable called speed, and this is going to be equal to the run speed or the walk speed depending on where the shift is held down. So our condition is if input.getButton run, that's the button we just set up, and so if that condition is true, so say question mark, then we want speed to be equal to run speed, otherwise colon, want it to be equal to walk speed, and we have to enclose all of this in brackets or parentheses, and let's see what's the problem here. I mean this needs to be enclosed in parentheses. Okay. Now we can see that we're walking, and if I hold down shift, I start accelerating to a speed of 12. Now, what we can create is a blend tree. So right-click, create state from new blend tree, and we can just call this blend tree movement or locomotion or something like that. And the way a blend tree works is it's got a blend value here which goes from 0 to 1, and we can add a whole list of animations over here, and it will sort of interpolate between them based on this blend value here. So let's add in a motion field. Well, we'll actually add in 3 motion fields, one for idle, walking, and running. And we can just open up our player here, and we've got all these animations. So let's drag in idle, and walk, and then run. Okay, and we're going to turn off automate thresholds, and we're going to set the threshold for idle should be 0, that's correct. And for the walking, well, we know our walk speed is 8, and we know our run speed is 12. And now we want to create a new parameter. We can create a float, and we can call this speed. And you can see that this variable over here has been renamed to speed, and you can change the parameter that controls this value over here if we had multiple. And the way we set this value is over here in our player controller. We first need to get the animator component, so we can say private animator, and we can just call it animator. Animator. We can say animator is equal to get component of type animator. And here we're going to say, let's see, where should we put this? Let's put it just before the input. We can say animator.setFloat, and the name of the float was speed, and then we can pass in a value, and for the value, say we just passed in current speed. Well, that's not really going to be ideal for 2 reasons. So the one is that the speed can be negative. Let's just click on our player here so you can see the value being changed here. So it's going from 8 to -8 or 12 and -12 if I'm running. But none of these are mapped to negative values, so we can actually just get the absolute value of that. So if we were to say mathf.absolute, hold on, mathf.absolute value of current speed. Now you can see that this is kind of working. The only problem is that let me just go into player physics and turn off the actual movement so that we can just look at the animations better. Okay, so first problem, of course, is that the player isn't actually changing direction, but we'll worry about that later. Just looking at the actual animation itself now as it transitions between moving left and right, you can see that the transition is a little bit awkward. It sort of stops the player stops moving and then starts again. We want something smoother than that. So what we're actually going to do is we're going to create in the player controller a new float, and this is going to be called animation speed. Sorry, it's of type float, animation speed. And the animation speed is just going to be always incrementing towards. So again, we're going to use this increment towards function, and pass an animation speed is the number we want to start from. And the target is going to be the absolute value of target speed. And for the acceleration, we can just have our normal acceleration. So now, over here, we're going to be passing in animation speed. Now let's go ahead and make the player face in the right direction. So at the end here, we can just say face direction. And the way we're going to do this is we're going to first want to get the player's movement direction. So we can just create a float and call this move direction or something. And this is just equal to input.getAxisRaw horizontal. Okay. And now we're going to say transform.Euler angles. So we're setting the rotation equal to, and we want to set the rotation to 180 degrees in the y-axis if the move direction is greater than 0, and we can just set it to 0 if it's less than 0. So we're going to say if move direction greater than 0, then question mark, we want the Euler angles to be equal to vector 3 dot up, which is 0, 1, 0 vector, and we can just multiply that by 180. And otherwise, we want it to be set to vector 3 dot 0. Now let's go into the player physics and can enable movement again. And we actually want this now to, instead of being space.self, we want it to be space.world. And the reason for that is that the direction that you're traveling in is determined by the input rather than now the rotation. So we'd have conflicting things where it's trying to go in the negative direction, but it's also trying to go relative to the transform. So that's why we're saying go relative to the world rather than relative to the transform. So now everything should be working except for one little error, which is just that you can see if we're walking and we stop, we suddenly turn around to the other direction. So when we're going here, it's fine, but if we're walking right and we stop, then we flip around. And so the reason for that is just in the player controller over here, move direction is no longer greater than 0, it's actually equal to 0. So we want to say if the move direction is equal to 0, or rather if it's not equal to 0, then we will set the rotation. Otherwise we just want it to keep whatever rotation it had before. And now everything should be working. So let's just let's create a little bit of a bigger platform to test on. And yeah, we can run along here. Whoa, I ran off. Okay. But yeah, you can see how everything's working. It's all good for now. We're going to want to add in jumping and all sorts of fancy stuff later on. But for now, this is a pretty good base. So see you in part 4. Cheers.